Hello, everybody, and welcome to the Kubernetes Online Master Class Series. Good morning, good afternoon, and good evening, depending on where you are joining from. We had over 1,000 people registered for this class. We are expecting several hundred to join from all over the world. And this is a new series that we are starting with Rancher Labs. Each class in the series will be about an hour long, 30 minutes for Q&A at the end. We'll cover several topics. For today, the topic that we are going for is building an enterprise Kubernetes strategy. But in the future, we may have other topics. We will have other topics like migrating existing applications with Kubernetes, Prometheus support, troubleshooting, how to run databases, security, building a cloud-native CI/CD, and many more. So the question really is, why are we launching this series? Well, we talk to thousands of users every month. We go to DockerCon, we go to KubeCon, and we repeatedly hear about the common challenges that users face as they want to deploy and scale Kubernetes, irrespective of the industry, irrespective of the company. Some of the challenges are very common, and they mostly relate to things that I mentioned: how to manage multiple clusters, how to deal with security challenges, how to best monitor your workloads, and many more. We also have an open Slack channel, and we get a ton of questions about Kubernetes best practices on that channel. And then finally, there are tons of resources on Kubernetes. If you know where to look and you know how to find what you're looking for, then there is enough information out there. The problem is that not everything applies to all the people at different levels. From those who are starting out their journey to Kubernetes to those who want to scale their current existing enterprise Kubernetes solutions. So the fact is that all of you are here, and this kind of proves what we thought. That we should solve this problem together. So we are hoping that with these presentations and your participation, we can finally deliver something that you, the real users, will find useful as you deploy and use Kubernetes in your enterprises. So today's topic is building an enterprise Kubernetes strategy, and I have with me Shannon Williams. So I'm going to introduce him. Shannon is a co-founder here at Rancher Labs, and he's also a member of CNCF governing board. Shannon has spent his career building or working at next-gen technology startups like Containers, Kubernetes, and cloud computing companies. If you're looking for a visionary and leader to talk to about containers and Kubernetes and cloud computing, Shannon is definitely one of these leaders. And I am Ankur Agarwal. I'm head of product management here at Rancher Labs. My job mainly is to define new capabilities and products for our users. Prior to joining Rancher, I was running Cubeship.io, which was a CA accelerator focused on container delivery. I've been in the DevOps and cloud computing space myself for over a decade, and I've been building products for companies like Mercury Interactive, VMware, and now Rancher. I'm very excited to be here, and I'm definitely excited about this session that we are starting. I'll be your host for today and as well as in the future in this series. I will also help you with Q&A. So I will try to answer as many questions as I can, and I will bring those questions up to Shannon. So you can keep sending those questions in the chat. All right, so with that, I'll pass it on to Shannon. Shannon, please take it away.
Thanks, Ankur, and thanks everyone for coming today. I'm really excited to see so many people here. I know a lot of you that registered probably know me already from the online meetups we run every month here at Rancher, or meeting me at KubeCons, or coming to presentations I've given all over. So it's great to talk to all of you I know already, and for people that are new, thank you so much for coming today. As Ankur said, the whole idea of the Rancher Master Class Series was to kind of get into kind of important topics that we get asked all the time and try to get succinct answers around them. And we've got a lot of topics. We kind of came up with this idea of walking out of KubeCon this year, and we were thinking about how to continue the conversations. We had something like 3,000 people come through our booth at KubeCon of the 8,000 people there, and it was so many people were beginning their journey with Kubernetes, and so we wanted to kind of imagine how to keep going. But one of the things I know, because I work closely with CNCF, is that only about 10% of the sessions that are submitted to speak at KubeCon actually get accepted. And I was talking to a lot of other people in the industry, and one of the things we thought was that it'd be great to take some of those sessions that the people were submitting that maybe didn't fit well into a KubeCon scenario and bring them to life online. And so the Masterclass series is going to be a complement to our online meetups and trainings that we run, and it's meant to focus on specific topics. Bring in speakers from all over the industry. We'll have presentations from users. We're having presentations from a lot of different companies. These master classes will be a little bit shorter. Our online meetups, those of you guys who attend them know, can easily run 2 hours as we present lots of different things and spend a lot of time demoing. Questions still always welcome. Use the questions app here and go to webinar to ask your questions. We'll try to respond to everything. No promises. We get, it looks like there's over 500 people here already. So I doubt we'll be able to answer all your questions, but please fire away. If we don't get to them live, we'll try to answer them for you when we get back in front of a computer later this afternoon. We are recording this. Like the most common question, are you recording it? And can I share it with people? Yes, we're recording it. We'll be posting it to a new channel up on the YouTube Rancher channel. So if you go to YouTube/C/Rancher, you'll find a new playlist that will be all of these master classes. So you'll be able to see them there. You'll be able to find them on our website. They shouldn't be too hard to find, but we are recording this. So, don't worry. If you'd like to chat about what's going on, we've created a new channel on the Rancher Slack. So if you're not already a member, go to slack.rancher.io. You can join there and then join the masterclass discussion. It's similar to our online meetup one. It's meant to have unfiltered conversation between you and other people who are on this. So it takes a few minutes. If you're already in there, please join it. Feel free to post pictures of yourself, what you're doing while you're watching this masterclass. If you're watching a recorded version, please join there and fire away with questions. We'll keep an eye on it afterwards as well. So if you're watching this 2 weeks later from now and you have all sorts of questions that weren't answered, fire them there. That's a place I'll certainly be in there answering, and Ankur will be in there answering questions that come in later as well. So with that, I'll kind of just wanted to highlight some of the upcoming classes we have. There's some great ones coming up over the next 2 months. We have a session that's the next one. It's next week. It's hosted by Chris Irwin on migrating existing applications to Kubernetes. If you haven't already registered for that, I can't recommend it enough. He's gone through some massive migrations of workloads to Kubernetes and has a ton of real experience with that. I'm really excited about Liz's presentation. Liz is one of the chair people of KubeCon last year, a good friend. She runs the security evangelism program over at Aqua. She's going into some really good just core principles for securing Kubernetes in the enterprise. There's a nice session coming up from the VP of Product Marketing over at Portworx, Michael Ferranti. He's going to talk about running production scale databases. And all of these presentations are geared to be, while many of them are being given by vendors, we are vetting these things to be, kind of about the problem and really trying to provide the same kind of quality you'd expect from a presentation going to KubeCon. So that's really the goal of what we're doing here. I'm excited about the one of the use cases presentations. The team over at Wizards of the Coast, the people that make Dungeons and Dragons, they're going to talk about how they've moved everything over to Kubernetes clusters and running that across different infrastructure on-premise, in the cloud, and really excited to hear their presentation coming up in May as well. So lots of great topics. If you have ideas, we haven't formally put this out there, but we are going to be kind of opening this up to a call for papers. If you have things you think would fit well and would like to present them, please don't hesitate. You can send them to me directly, just at shannon@rancher.com or info@rancher.com or Ankur@rancher.com, and we'll certainly respond to you and kind of would love to have more speakers, more people presenting cases. So looking forward to all of these sessions. So with that, I want to dive into our topic today. We are going to be really trying to nail down and have a really good discussion about what it takes to build an enterprise strategy for Kubernetes. And an enterprise strategy is what we want to cover here is not the kind of core question of what is Kubernetes or why is it important or what do you use it for, but rather, once your teams are using it, how do you build a strategy internally to deliver this, or to understand it, to manage it, to ensure its compliance with your organizational requirements? And what we'll do is we'll talk a little bit about where Kubernetes is today. And I think this is kind of one of the first questions that I tend to ask the first day I arrive at a new organization that's invited us in to talk about Rancher, is just help me understand where Kubernetes is at. What are you doing with it? Who's using it? How is it being used? And it's actually often the hardest part. The bigger the organization is, the more likely that nobody knows. Kubernetes, like Amazon before it and VMware and other things, it has a tendency to be adopted at lots of different levels by lots of different teams. So determining kind of the where, why, and how is a big challenge when you're an enterprise using this. And we'll talk a little bit about kind of figuring out that, and then beginning to get visibility across it all. It then begets maybe the most commonly discussed question when I give presentations like this, which is that who should own it? Who should own Kubernetes? And there's no good answer. We'll talk about a lot of different options, things I've seen, and I'm interested in your feedback on this. We'll then talk about what does a Kubernetes as a service look like? What does it mean? Is it Kubernetes as a service? Is it namespaces or clusters as a service? Should it be? Does it make sense at all? So we'll talk about that. We'll talk about standardization. We'll talk about shared services, and really that's going to be the bulk of our conversation today. Is how how organizations are delivering this as a platform. Is it how do you do that without avoiding kind of killing the innovation that's happening around containers and among DevOps teams that are leaning into using containerization to accelerate their productivity. So lots to cover. We've got, I am notoriously slow and run late on things, so I will try to move quickly. And Ankur will be kind of trying to answer your questions as they come in and slowing me down if there's questions that are kind of repeated, so feel free to fire it off a couple times. So with that, it's kind of easy to get excited about where we are right now. I mean, Kubernetes is certainly at the peak of people's attention, right? I mean, if you think of the classic Gartner curve, we're right in the middle of, we're right like staring down the trough of disillusionment, right? Everyone's talking about Kubernetes. We had 300 plus companies now in the CNCF, 8,000 people at KubeCon. There's no shortage of articles and companies and talks about Kubernetes out there right now, and it kind of holds up. This is, I pulled some data from our survey last year of the CNCF, looking at how people were adopting, what people were using to manage their containers with. And what you see is that, it's kind of past the point where there's much debate about how much adoption Kubernetes has. More than 80% of the teams are using it. It's been kind of the leading proponent for more than 2 years now. It just kind of has really, in the last year, it's kind of really locked in. This is what most teams are selecting. You do see some interesting things if you kind of look at the term. Mesos has been declining a bit. Swarm sort of leveled out at about 20% of teams are using Swarm in some capacity. Cloud Foundry has been consistently declining as a way of running containers. You see Amazon ECS growing, and I think a lot of that was happening also before some of the cloud providers started offering Kubernetes itself as a service. So there's a pretty strong indicator that Kubernetes is going to be the way we build containerized applications and operate them for some time. All this technology is cyclical, so I never want to bet on anything lasting forever. But we really are in the middle of a heyday for Kubernetes adoption, and it's not just that people are using it; it's where they're using it. The other big change we've seen over the last 24 months or so is a kind of push to production. In the early days, people's deployments were almost predominantly, everyone was using this for test and dev, and only maybe a quarter of people were actually running production applications. Over the course of the last, 2 years, that number had jumped pretty quickly up into the high 70s, mid 70s. And so, 3/4 of teams using Kubernetes were actually running production workloads, and that mirrors what we see. I mean, at Rancher, we work with there's about 20,000 teams that use Rancher every day, and so we get a lot of data and feedback on how people use it. And for the most part, Kubernetes is kind of designed for production. I mean, the reason people use Kubernetes instead of just running containers natively is they need sort of the failure handling. They need the orchestration. They need to be able to deal with hosts going down. They need some resiliency. So it makes sense that among container adoption, Kubernetes, which is a very good operations platform and offers a lot of resiliency, would rapidly become the place that containers in production live. And that's certainly what we see every day. And it makes a lot of sense, right? The enthusiasm is basically tied to, in my opinion at least, it's really tied to the impact of containers, right? While Kubernetes is amazing, containers themselves are really the sort of transformative innovation in the space. They're an excellent way to do testing, to share code. Their portability is well defined. We all know how easy it is to create, how quickly they come online. So I think most people would still agree that the value of Kubernetes is directly linked to the value of containers, and that a container's ability to package up almost any code and run it almost anywhere is what spawns the requirement for Kubernetes. But Kubernetes really delivers the operational capabilities that people need to actually put this stuff into production. It's a very production grade platform. It's very stable. It is it's got an incredible ecosystem developing around it of technology to allow you to do a lot of things like secure it, and we'll talk a lot storage services for it, monitoring services for it, logging services for it. So we're seeing just like in the case of Amazon and VMware before it, we're seeing a platform emerge based on a really key piece of innovation, the ability to quickly create packages of code and launch them, with now a lot of effectively in a lot of ways the same stuff we've always had to deal with: storage, networking, operations, monitoring, security, being re-implemented on this new platform. And we're enough years in now. I mean, we started Rancher in 2014. Kubernetes was started around the same time, around 2014. You're seeing this stuff now get 3-4 years in and achieving a certain level of maturity. Last slide, kind of talking about the survey last year, but I think it's worth kind of highlighting that there is still key challenges people bring up. When we are talking to organizations about what's their experience with Kubernetes and what's kind of impacting their adoption of it, it's usually it's been changing. We initially it was a lot about how do I do storage, how do I do security, how do I do monitoring. Those have been coming down. You can see monitoring and security are still on the list, but if you look at what's really kind of causing most of the consternation now, it's all around operations and sort of expansion, right? It's like getting the development and DevOps teams to use it correctly, kind of implementing the sort of cultural change, the complexity, just the overall complexity. And I think complexity is something we're going to talk about a lot. But the complexity associated with Kubernetes is rising, and people are running into that. They're finding people that are, it's hard to get people trained. We did an assessment last year of some of the support incidents that we dealt with. And, probably more than half of the support incidents we found, the root cause was more about people not really being well trained and understanding even how to use Kubernetes and its best practices. And one of the reasons we're running this series is to try and look at some of the areas we can provide more knowledge and pass more knowledge in. So I think these are spot on. I mean, they're all pretty similar. You notice that it's not like it's a 90%. Everyone's kind of dealing with different parts of this problem, but I think the top three all reflect the same thing, which is adoption is sped up, but it's not necessarily come really smoothly, that there are fits and starts and there are a lot of challenges building these things out. So if we kind of begin to look at our second question, which is less about why Kubernetes and where is it happening, it's more about what's going on inside of your organization. So to begin the process of figuring out an enterprise strategy for Kubernetes, we really need to understand how it has taken hold inside the organization. So I can tell you from the experience we're seeing, there's still no question that the most common place we find Kubernetes is something that's been implemented by a team, typically with some SREs and DevOps experts on the team, to run a specific app or set of apps or workloads that are tied to a business function. So, every conversation tends to start with, we're running this to implement application A. We've got it hooked up to all of our monitoring tools. We've kind of built out Kubernetes for our team, and we're running this version, and this is how we're implementing it and why we're implementing it. And it makes a lot of sense, right? I mean, Kubernetes is not, there's a lot of ways to get it. It's not a particularly difficult thing to get up with. It's probably aligned again with signing up for maybe a little harder than signing up for an Amazon account, but not dramatically harder to build out as Kubernetes. In fact, it's getting easier and easier. We are seeing a lot of use cases on the edge. You know, a lot of places where people are trying to put Kubernetes less and less for its sort of scale out capabilities and more for its ability to package and deliver software into stores. There's a great use case last year from Chick-fil-A where they talked about every store in the country getting a 3-node Kubernetes cluster, and Target's shared some use cases like that. There's you know, there's a lot of use cases in the telecommunications space where people are putting this stuff in base stations. We're working on it with a bunch of different people who are putting it into satellites and satellite uplinks and, you know, things like factories. So I do feel like you're seeing a broader implementation of Kubernetes and containers as a way to easily update remote locations and remote pieces of software. So that's another area where if you're not thinking about it, you're probably going to see some of that. You know, where there's still some challenges, just the weight of Kubernetes sometimes makes it impractical for those use cases, but there's a lot of projects going on right now to impact that. And I think as a general rule, we don't see organizations running one Kubernetes, right? It's often deployed lots of times throughout an organization by lots of different teams, you know, with often lots of different versions and stacks of software. In fact, I think that's maybe the, you know, if I had to say the defining characteristic about, you know, the container movement or whatever you want to call this phase of technology we're in, is that it's very decentralized. You have lots of teams implementing it. They implement it in their own ways to meet their own requirements with a focus on achieving their own agility goals. And in a lot of ways, it feels like kind of a response to, you know, kind of the classic pendulum swings between IT and DevOps, where, you know, IT implements a big platform and DevOps kind of goes off and does things their own ways. And you know, Kubernetes is interesting because, you know, even when I set up a single cluster, I get a lot of configurability. I can choose the infrastructure I run it on. I can choose, you know, what version I use, how I manage it. But I also get the ability to kind of offer a service to my team where they can be given namespaces. I can give them a certain amount of autonomy to go and build their own things. We can set up Helm charts and pass them around, right? I can build almost a service that services just the group of people that I'm working on. And that's such a common way to see Kubernetes appear in an organization. It's one of the reasons, you know, I think I was at a place 2 weeks ago and they had 58 independent clusters being deployed, you know, and this wasn't a Fortune 10, this was maybe a Fortune 500 company, but still 58 different clusters that they knew about, you know, and one of the reasons for that is the ease of use, right? If you think about, you know, if I just want to roll my own Kubernetes and manage it myself, you've got a lot of different tools like Kops and KubeSpray, Ranchers. We've got our own thing called RKE. There's still always Kubernetes the hard way. You can go follow Kelsey's approach and build it yourself and learn the ins and outs. There's kubeadm. So there's a lot of tools that make, you know, they're kind of geared around setting up Kubernetes. There's tons of different Chef, Puppet, Ansible scripts. There's, you know, a lot of things you can do with Terraform to bring things up and get a Kubernetes cluster implemented. And so even if you want to kind of have all the customization and build your own cluster, there's lots of choices. If you want to take a hosted Kubernetes, it's even easier, right? I can go to any of the cloud providers and within 10 minutes, I can have a Kubernetes cluster that's deployed for me and running, and that's anywhere. So you can imagine, you know, this is a little different than 2 years ago when my only choice was really to kind of set it all up, to build it myself and configure it. Now, you know, there's just a lot of ways to get a cluster up and running, and there's a lot of ways to get that cluster sort of onboarded and begin to start using it pretty quickly. And so I think there were some early belief that we would have sort of you know, organizations would run really large Kubernetes clusters that everyone consumed, and they would be sort of a shared resource. And that is happening in places, especially for large workloads. But it does still tend to be much more common to see Kubernetes, you know, freckling the entire organization. And I don't see any slowdown of that, right? I mean, once you make it available as a cloud service that anyone can launch, the idea that you're just going to have one probably isn't realistic. You're going to have a lot of people launching them for lots of different reasons. And so we're probably headed towards a world of multi-cluster Kubernetes. And that's, you know, means that inside the same organization, it's not uncommon to have these clusters running in very different places where different teams have implemented it to their spec, running their services, you know, kind of geared to their application stack, geared to their tool chain, on the infrastructure that they have access to, or that meets their requirements, or that's, that they have budget to consume, or every reason you can imagine, to put it out there. The breakdown, people ask me all the time, well, what do you see the most? Where does this stuff run? I would say it's probably about half and half between cloud and on-premise infrastructure. And among cloud services, Amazon is obviously the largest, but there's a lot of Azure, there's a lot of Google, there's a lot of DigitalOcean, there's everything. We see people running it on, even in the big Chinese cloud providers and other things as well. So pretty good mix. I would say on-premise, it's probably still about 70% running on VMware, maybe 30% running on bare metal. So pretty broad set of where things run. VMware, and some virtualization, it could be OpenStack, it could be something else that I'm using to manage creating VMs on-premise. But whatever that infrastructure is, the ease of provisioning the infrastructure tends to be the reason that Kubernetes gets there instead of ending up on bare metal. And it makes a lot of sense, right? VMs offer still a good way to sort of slice up resources and delegate them to different purposes. And if you're going to say that this is a 6-node Kubernetes cluster, you may not really need that much capacity. It may be more about the resiliency. I talked to one team where they explicitly were trying to run Kubernetes for every application. Some of these were really small, 3-node clusters. There is, though, every Kubernetes cluster requires, some overhead. You need an etcd, you need Kubernetes masters, you need to run these sort of services, ideally in quorum. So think your 3 nodes to kind of keep your Kubernetes cluster live on etcd, and maybe another node for the management server. So the idea of running really small clusters, at least at the current architecture, is somewhat suspect because the cost of it is very high. There's benefit, obviously, but there's trade-off. And one of the things people like a lot about the cloud providers is that in many cases those management planes are provided for free. So Google and Azure don't charge you for the etcd nodes and for the management server nodes. You just pay for the infrastructure you use, and you don't really pay a premium for it either. Again, pretty good value. Amazon still charges kind of a premium for their EKS service, but there's different. Now, these things aren't all the same. I will say that the cloud services are different. They are running different versions of Kubernetes. They sometimes have different services taken off, so they're not super configurable, but their ease of use is very high, and their operational effort required to maintain them is relatively low. The operations are done by the cloud provider, like everything else you get from the cloud. So pros and cons of taking these things come into effect. And so all of this expansion of adoption, this teams using it everywhere, is kind of drawing a lot of IT attention to Kubernetes. And so you get to the point of asking, who should be responsible? How do we fit it into our overall cloud strategy? Can we deal with this as a service? Should we be able to kind of run it on top of our existing infrastructure investments? How much should we be worried about compliance? What other services do we need to provide around it? How do we get into accelerating the adoption? I mean, these are all the classic questions you would imagine. And you could have taken this exact same list, put it up against Amazon 5 years ago, 4 years ago, and we'd be kind of in the same space saying, yeah, I think we're in. Kind of IT is feeling more and more comfortable with it and beginning to look at it and say, we can take this on. And so, the reason for that is that they actually have a different set of benefits potentially than the DevOps teams who initially were picking Kubernetes. On the one pound, they do really care about accelerating innovation. And any IT organization's core goal is about supporting the DevOps teams and the developers who are trying to build applications. So there's no question that if they can deliver value that they can point to and show how they're improving productivity, it's a big win for IT and for the IT organization at central services, shared services, whatever you want to call this function. But there's other benefits, right? For them, there's potential to significantly use the standardization that Kubernetes offers to reduce costs, reduce risk, improve operational maturity. At the end of the day, nobody loves standardization more than people who have to manage a wide variety of things, right? If anybody in the organization's ever beaten consistently the drum about the benefits of using one approach everywhere, it's the IT organization that has to sort of adapt to a constantly changing, situation on the ground. And so the idea of one platform that can run on VMware, run in the cloud, is very appealing from an operational perspective. And on top of that, most of these teams have some goals tied around achieving hybrid cloud, getting into kind of a multi-cloud, hybrid cloud, run applications anywhere consistently. So, on its face, Kubernetes, it should be good for cost. It gives a lot of density. It allows the teams to have, ideally one platform that they can monitor and have visibility across. So consistency of package in the case of just the container, and consistency of orchestration, these are big wins for IT. So it's not surprising that IT, upon sort of seeing adoption happening and teams getting benefits, looks at it and says, this actually lines up really well with us. And the fair, to be fair too, while there's all these pockets, I used the word freckles earlier. I always think of that because the body of IT is pretty massive. The body of applications in an organization is pretty massive. It's fair to say that things like Kubernetes and containers today really are kind of freckles or moles or whatever you want to call it. They're 5%, 1%, certainly less than 10% of most organizations' IT consumption is containerized. So the natural then question is, well, so who should own this, right? IT begins to see a lot of value that they can deliver around it. And obviously the development teams and DevOps teams who are built their own Kubernetes and are running themselves see a lot of value. There's there's no right answer, obviously. There's a lot of debate and discussion about this, but I will tell you that when we go through and talk to organizations about this, they're kind of consistently we see the same kind of discussion. Should we leave Kubernetes and this service as something owned independently by all the application teams and development organizations, or should we bring it into kind of a shared services team that offers Kubernetes as a platform or as a service to its development teams? Should there, some teams have kind of a central DevOps function, maybe not at a global level, but maybe at a departmental or division level. We see that quite a bit. There's obviously the traditional ITOps, the people who own VMware and data center operations and the network and a lot of other kind of central functions, enterprise architects. Very often, this is where things start to land when centralization begins. This is who owns, maybe VMware. There could be a team of cloud platforms and strategy group. This is more and more becoming part of IT. So IT has a team that sort of manages their relationships between them and Azure and Google and Amazon and whoever else they're working with as a cloud provider. And so all of these, at times make sense. We even see kind of teams where they put something like containers into an innovation group. Though I always say that that's like the hardest. It's much better when you either have the app team that's really pushing to get Kubernetes adoption amongst their own teams, or the IT organization own it. At the end of the day, it probably you can certainly succeed either direction. But I would say the trend over time is that for broader services that are widely adopted, they're most likely going to end up in some type of shared services function, either owned by a DevOps team or owned by the IT ops team, but where the teams are not, everybody's not rolling their own approach to Kubernetes. So, when we start thinking about that standardization and that centralization of the function, there's a lot of questions that go into, how do we do it, and how do we do it without really impacting all the benefits that people are getting, right? I mean, one of the things that people love about Kubernetes is they have a lot of control, right? I have my own cluster. I can, share it with the right people. I can set up the privileges the way I need to. I can mount my own storage services that I want. I can choose the cloud they run on. Right? There's an enormous set of benefits to a decentralized approach. You can optimize the whole thing around the innovation you're trying to achieve, and you don't spend too much time worrying about consistency because you're just focused on innovating and getting what you need out of the platform. So the benefits are pretty clear if you're kind of decentralized, but there are a lot of benefits to centralizing, right? I mean, the idea of upgrading 20, 30, 50 clusters that are running different versions, and potentially the person who built it has left. The systems are totally unintegrated. There's no consistent, tools to do these things. Moving between projects is really hard for an individual because they kind of, maybe they know Kubernetes, but it turns out this version is 3 versions old and they haven't upgraded it lately. So now they're trying to figure out how to bring that whole platform up to speed. Very hard to focus on any kind of consistent security and compliance when you use a decentralized approach. People do. I mean, they certainly audit and there's approaches to it, but it's harder. You're adding a lot more. So this is the decision everyone has to make, and trying to find the right balance here is kind of the key to this whole presentation. What is the key to building this enterprise strategy is about, kind of understanding what a Kubernetes service might look like, and then building it in a way that ideally left as much of the benefit of the Wild West that we have today while still getting some of the benefits of the centralization. And so, we head into this with kind of an expectation that Kubernetes as a service is going to be part of an organization strategy. I think it's still more often I see it called container as a service or container management platforms or whatever, but I think of it, it really is about delivering Kubernetes right now, and or managing Kubernetes or implementing a framework around Kubernetes. And so this is where we're heading, and I think for a lot of organizations, they're already beginning this journey. They're already on this journey in different ways, but not everyone means the same thing when they talk about it. So when I say Kubernetes as a service, what I'm really talking about is, where the IT organization and the DevOps teams that use Kubernetes are coming together on a common platform that allows the teams to get access to a Kubernetes cluster, to run exactly the workloads they need, to get some level of configuration and operational capabilities around that cluster or the namespaces that they've been allocated, and at the same time for IT to manage common functions, provide a lot of key integrations like Active Directory or user management, plugins to approved registries, define policies, say what is allowed and not allowed to run in the cluster, what kind of what image scanning is required, what type of pod security policies are necessary, what infrastructure can Kubernetes run on, and finding the right balance is still not guaranteed by doing this, but implementing something where these teams come together and there is a shared platform that focuses on deploying and running these different Kubernetes environments for the different teams that need them. When you kind of dial down into this and you kind of think about what some of the big questions are, for sure the requirement to do this is multi-tenancy, right? So we have to be able to deliver isolation between the different projects in different ways. And we're probably, based on everything I'm seeing, there almost absolutely has to be some level of multi-cluster management, even if it's just, running different geographic clusters in different parts of the world. And I think that's at a bare minimum, there's going to be more than one Kubernetes cluster. So we kind of set a minimum expectation that we have multi-tenancy and multi-cluster management. And then the next really big decision is, what is the level that you're allocating? Are you delivering really kind of clusters as a service or namespaces as a service? And this is a debate I've seen go both ways in different organizations. And I've also seen a lot of teams find this as a hybrid, that they find a hybrid where in some cases they allocate clusters to different use cases. In other cases, they allocate just a namespace. The good news is, namespaces are well isolated. There's a lot that you can do to actually allocate capacity at a namespace level now and set quotas for namespaces. So it's certainly possible to use a namespace as a service approach, but there are definitely advantages to cluster as a service. The first is really true isolation. If I set up a cluster for an organization, they have really complete isolation at the hardware level, or at least the VM level, from anyone else using their infrastructure. And so clusters as a service allows me to delegate a lot of operations down to the teams. The cluster could be, maybe I can give them some choice about where it runs. I can give them some choice about the type of CNI or storage plugins that they want to implement. So I can very easily do chargeback. If I'm an IT team, I can easily understand this is this cluster, the operational cost is X plus the infrastructure cost is Y. That's the chargeback for the team that's effectively been granted a cluster. There's certainly more flexibility. One of the things you find is that a lot of tools that actually run on Kubernetes in different ways require some level of cluster admin rights. We see this all the time where tool kind of assumes that the cluster admin will be using it, but it actually applies just as well to someone who has a namespace. And so, the cluster as a service model, it doesn't have as good a density, but it has really good isolation and flexibility. If you need better density and you're looking to, kind of just give people a place to run their containers, and they're more than happy to sort of follow a consistent framework or pattern, namespace as a service is great. It allows you to, run fewer, there's less management overhead, right? You can have just one of the, etcd control plane level thing at the cluster level instead of wanting one for each team. So it should have an operational efficiency there. You also will be able to improve the density by running more workloads on the infrastructure you've allocated, right? It's kind of a given that you're going to be able to get more workloads there than if you're sort of dedicating entire clusters. You're just dealing with smaller grains of sand. You can easily centralize the cluster operations here. You're not dealing as much with different potential configs. When you do cluster as a service, you might even have different versions, right? Cluster 1, the team needs Kubernetes 1.12. Cluster 2, the team needs Kubernetes 1.11 because of some driver they wanted to use or some storage plugin. Cluster 1, the team wants to be in the cloud. Cluster 2, the team wants to be on-prem. Right? If you're doing, just one large cluster, you could potentially even do a large cluster across different types of infrastructure. You could run a namespace that uses tags to just put workloads in, say, on-premise VMware infrastructure, and that same cluster could theoretically, if you had good latency, be running in a colo facility or an Amazon or something with Direct Connect. So there's a lot of things we've seen people try to do to get more of this. I would say that the overhead of running clusters is moderate. It's not really high, and so almost every organization I'm seeing right now is ending up doing at least some level of cluster as a service, even if their prime focus is on namespace as a service, because they are they're finding that they need to do they want to run different clusters in different places. And when you think about the sort of process, this is the other area where the IT team spends a lot of their team building strategy. So as you're building a strategy out, if you're using cloud-based Kubernetes services, you really need to kind of ask yourself questions about how much config do you need, how much do you need to actually work with other cloud services, because you then have a choice. If I'm in Amazon, I have a choice between running EKS or running my own Kubernetes, and there's again pros and cons. If I use EKS, I'm going to have less operational overhead. They're going to run it and upgrade it for me, and Kubernetes will just be something I talk to an endpoint on. If I run it myself, I can choose how it's configured, when it gets upgraded, what it which version I'm using, and all the plugins I want to use. But now I'm on the hook to maintain it and upgrade it. So one nice thing about running your own Kubernetes everywhere is you can standardize. You can actually run the same versions across multiple places. Potentially, we're gonna have Portworx talking later, but there are tools like Portworx or Longhorn or things that are storage services that are also portable and stuff. So you can potentially have a very consistent infrastructure experience across different clouds. But again, is that worth the cost of having to maintain and upgrade? Kind of key questions about, if I'm in the cloud, do I use the hosted services? Do I run my own? How valuable is standardization versus ease of access? And the same questions kind of happen when you look on premise, whether you want to run on virtualization, whether it's VMware or OpenStack or whatever, or just go straight to bare metal. Who's actually going to own the process of upgrading these things? What level of redundancy do you want to have? I think, one of the things we certainly are seeing in almost every enterprise deploying Kubernetes is a realization that Kubernetes, while it can span failures domains, right? I can have a Kubernetes cluster that crosses, 2 implementations of VMware or 2 Amazon availability zones. It doesn't change the fact that Kubernetes itself creates a new failure zone. It creates a new set of software that's being managed by someone that could be down, could prevent me from doing upgrades. And so almost every organization we're talking to is kind of changing their thinking about Kubernetes and thinking of, even though it is a very resilient piece of software, it's very good at failing safe. Just the nature of kind of it being software means we need to think of it more like an availability zone than like a region or a cloud provider, if you're kind of thinking in Amazon context. So, again, it leads to building multiple Kubernetes clusters and distributing workloads ideally across them, distributing failure zones across them, so that if I have an issue with Kubernetes cluster 1 for any reason, I have an ability to spin up more resources in zone 2 and handle that. So that concept kind of reinforces the need for multi-cluster management. There are a lot of really easy opportunities, though, for sort of wins on the centralized management side. So when you're building out the strategy for for Kubernetes. I mean, the big ones right off the bat is centralizing all of the auth and RBAC and controls. I mean, if anyone's built RBAC policies in Kubernetes, they're pretty detailed. You can do almost anything. You have really very nice fine-grained controls, but you need to then build those as roles and apply them universally. And all of a sudden, you've got different clusters, and it becomes really hard to have any concept of what people can do and what they're not allowed to do. And again, tying that to your auth systems so that you're removing people when they leave the company, is obviously becomes really important as well. So the big wins right off the bat are you're going to definitely centralize all your management of users and their privileges and who's allowed to access which clusters, what they're allowed to do in those, who's allowed to access which namespaces, who has the ability to invite people into things. You can do that very easily with a Kubernetes service across different clusters, across different implementations. The security area is the other really obvious win for central management. This is the one that really drives, this is sort of the cudgel that IT uses to force people, to adopt every service that they deliver, which is, hey, we are going to put the investment into coming up with a secure way of using this on our networks, inside of our, firewalls. And a lot goes into this. Pod security policies, we see this pretty consistently. People define them centrally and then set them as a requirement for what's allowed to run, what kind of privilege people can have on a container. Those are the type of things that get set globally and applied to any cluster. Image scanning, a lot of third-party security tools we see as a really common global policy that, this agent has to be running everywhere, right? Whatever it is, Twistlock or Aqua or NuVector, one of these things. So the IT organization is going to own, ideally, the security tools and policies for the team, and then define those, apply them, and have them just kind of codified in from the beginning when new clusters get created or when a cluster is onboarded in some way or imported to the platform. The registry is another area, whether that's an Artifactory or Harbor or whatever it is. Often another big win that teams get pretty quickly is application catalogs and using Helm as a global service, sharing applications, creating kind of a global set of apps. So these are pretty easy wins. There's not much pushback, I don't think, across the board, that these are great things for IT to own and to help deliver. They take the effort off of the teams that would otherwise have to get them. And many of these services are just better the bigger they are, right? The bigger your application catalog is, the broader it is, the more likely it is I can find something of value that someone else has created that might streamline what I'm trying to do or solve the problem I'm trying to do. So that's all good. Training becomes easier, obviously. Encouraging adoption becomes easier. The harder part, I would say, is when you move to then kind of offering more of the shared services on top of Kubernetes or around Kubernetes or implemented with Kubernetes. And there's some of these are easier than others, but when we think of a Kubernetes stack, we're talking about a lot of pieces of technology working together, from the infrastructure we run on to the Helm chart at the top. The most common areas where I see people implementing kind of shared services around Kubernetes are in kind of the DevOps toolchain. So CI/CD tools, monitoring and logging tools, very common now for Prometheus to be offered kind of as an available service on a Kubernetes platform. And it's nice, right? It's great to be able to say, oh, great, I'll use this. But for the most part, most DevOps teams have preferred monitoring tools, preferred logging tools that they're already comfortable with, that they're maybe using at the application level or they're using for other components of what they're doing. So my recommendation in this area is always, kind of take the pieces that are easy to share, centralize, and sort of focus on those. You think of the app catalog, access control, obviously the orchestration layer and the config database for that, maybe the registry, but in areas that are more where there's a lot more likelihood of having teams want to run their stuff, just make this stuff optional. Don't make it mandatory. Don't force people. Don't tell people that you need to use Fluentd and Prometheus or Loggly or whatever it is that you've got, or certainly don't push CI/CD as a mandatory requirement that we've delivered this really nice Bamboo implementation. That's the only way to do compliant builds for our organization. You've got to be more flexible there. So the areas like that, service mesh is another good example where it's still really new. A lot of people aren't sure what they're doing with it. It's likely that you can, feel free to offer these as services. Say, hey, look, we've got some expertise on this. We can host Jenkins for you really well. We can host Istio. We can train you up on it. We've got expertise on our team. But these aren't places where I would suggest at the moment there's not enough consensus to focus on standardization and to push this through. I think in many cases it's the attempt to take this whole stack and tie it into one thing that has slowed down the adoption of PaaS, and people that have kind of have taken very opinionated approaches and certainly shown real benefit, but have seen very little adoption at the end of the day by the team. So think of this as your palette that you can pull from, and ideally, as you're building out this Kubernetes platform, some of these things can be optional and some of them can be kind of configurable, and other things are chosen by the infrastructure team that's running the Kubernetes, right? Like the container engine is a pretty good example of that, right? We're probably gonna run a consistent daemon for actually running containers everywhere. Whatever that is totally reasonable to choose. Storage might not be. Storage requirements differ a lot. So storage is a pretty good example where you might have a default, but then also have a pretty good approach to allowing teams to bring their own or choose from a cloud provided sort of storage service, or maybe choose from a pretty good long menu of options that might fit with their requirements. But again, the more you can be flexible here, the more likely that you'll find a lot of teams wanting to adopt this shared platform. Okay, a couple more slides and then we'll get into questions. So there are really three kind of primary options, I would say, for building Kubernetes as a service today. The one that I run into a lot, especially the bigger a company is, the more likely they are to adopt this, or the more that they, earlier they were adopting Kubernetes, the likelier to do this, and that is kind of your build approach. You can, build a tool, a set of scripts and tooling and technology to create and launch Kubernetes as a service. This summer I spent a lot of time with an organization that had built out a very large Kubernetes-based platform. They had 6 really good engineers. They built a really nice workflow. They really understood what their developers went through. They had, they went all the way down to just give us your manifest and we'll build the containers. We'll do the CI for you. We'll push to staging, push to dev, push to test environments. Like, it was very geared to what their build and development process looked like. It was a mix of all sorts of tools that they were using. There was a lot of code that they developed, and in this case, the team. I mean, it kind of highlights the last point. This is really flexible. As long as you're investing in it for the long term, it's certainly a viable option. But it has the common challenge of every sort of custom-built software. It's hard to maintain. It is hard to keep up. I think the reason this team, had some of the people leave, and they pretty quickly ran into problems where they were running on, about 10 to 15-month-old versions of Kubernetes, and they were just not being able to get the latest features. They were dealing with issues and kind of reliability, and so they started to realize it probably was more. So then there's open source tools. Rancher. This is what we build at Rancher. Rancher is an open source platform for doing Kubernetes as a service, but there are others. The two that kind of jump to mind: OpenShift Origins from Red Hat, and DCOS, the open source project from Mesosphere. Both of those are also kind of geared for teams trying to build and deploy an open source Kubernetes as a service platform. OpenShift only is sort of a single cluster, so they would only really work for that namespace as a service, and they wouldn't be able to support, say, hosted Kubernetes like GKE or EKS. But if you're running on premise and you just need sort of one cluster, they'll deal with a lot of that user management and policy management types of things that would allow you to kind of invite people into a shared service. DCOS, kind of same sort of thing. It runs on top of Mesosphere. They recently added the ability to do multiple Kubernetes clusters. Again, it needs Mesos. It needs to be running their Kubernetes. You can't really take GKE or EKS or hosted ones. There's also a whole bunch of commercial-only products that are available that do this. I put Rancher on there because we offer support to the open source, so it's kind of a commercial option. OpenShift has a product that is slightly different than Origins, that adds more stuff. Mesosphere's version of DCOS adds more features. VMware Docker Platform 9, there's a few more people that offer sort of commercial versions. You could just go with a cloud provider, right? You could just partner up with AWS, and AWS is your provider, and they do all the Kubernetes clusters for your team, as long as you don't need to run anywhere else or need to have any changes to Kubernetes. That's a totally viable option as well. So if you look at your options, lots of different tools for building things like this. I think the market is heading in this direction, that that we expect Kubernetes to be a cluster level technology, and that there will be management around it, on top of it, to build things here. I certainly expect there will be SaaS hosted versions. There's a few things out there already that are coming where people are going to build SaaS things that manage multiple clusters in different places. And there are a lot more names that I didn't put on this list. So depending on what you're looking for, there's a lot of ways to build this. There's a lot of ways to use an open source product for this. There's a lot of tools that you can buy that are kind of geared around solving this type of problem. I thought I'd share, to wrap up our stuff, we're going to run out of time in a few minutes, but just one case study that I thought was really spot on with this use case, and that was the team at Illumina. They are they're one of the leaders in genetic sequencing technology. They build all the genome sequencing tools that are used by hospitals and drug manufacturers and all these companies that can tell you where your ancestors came from and such. And so they were, a year and a half ago when I first met with them, and they were doing a lot of different types of containerized workloads. At the time, they hadn't even standardized on Kubernetes, but they were heading that way. And what they found was they really had very distinct requirements for different teams. The teams that were doing deep learning and machine learning and AI stuff had a set of requirements. They had a bunch of things happening in IT that were being built. There was a set of applications that were more core business applications servicing their customers. And initially they were doing this across a lot of different types of systems, each one run uniquely and independently. As they built out, they chose Rancher, they used the open source Rancher to start with, and then started working with us as a customer down the line. But what was important to them was they wanted a consistent experience for all of these teams, and then they were able to basically build out on-premise bare metal infrastructure for use cases that had a high density opportunity in places where they had predictability in their workload. They said that they felt that the cost of using on-premise bare metal was dramatically cheaper than using public cloud for their workload. So they ran a lot of things, especially their deep learning and very data intensive stuff on infrastructure that they owned. But they also had a lot of things that they wanted burstability, and they wanted Kubernetes to be running in Amazon. So they blended those two things into a consistent platform, running them both. The IT platform team that runs this whole thing owns policy. They own the registry, they own the monitoring services of all the infrastructure. They deliver quite a bit of flexibility. They chose to do more of for the most part, a Kubernetes as a service, but there's kind of a hybrid model where you get or clusters as a service, I should say. You get a cluster if you're like a department or a team that needs a certain amount of isolation. That's kind of the chargeback layer, is at the cluster. But within there's a lot of namespace as a service. I think in the last year, they now have 14 production clusters. They've centralized all of the compliance and controls. They've implemented global approach to security across these things, and have effectively Kubernetes as a service for 300 developers in place now. And big things they've been adding recently are around kind of improving the onboarding of existing applications, doing more training for teams, and it's been a really successful project. I think that's the direction that's out there, is to take this stuff on pretty easily. You start with the first organizations that are using it, build some of your policy. Start with the people that are the early adopters and get some consensus. One thing that I do feel like there's a natural tension between IT owning this and the DevOps teams owning it, finding commonality, finding that win-win. There are huge benefits to both, and if you can find that middle ground where policy doesn't sort of impact innovation, it's much more likely to succeed. At Rancher, this is I'll just kind of leave you with a couple thoughts on who we are and what we're doing. I mean, we're an open source software company. For those of you who don't know us, everything we do, we build as open source and provide for free, and then sell commercial support on those open source products. It's sort of like Heptio, not Heptio, but HashiCorp. And so if you are looking for something that allows you to kind of bring any Kubernetes together and provide centralized operations, I would highly recommend looking at sort of the Rancher open source product. It's very broad in terms of its ability to manage existing Kubernetes and geared around this approach of deploying policies. You can set it up in just a couple easy steps. You just sort of launch a single server, and the Rancher server can get started on there. You can kind of run it at scale, and there's lots and lots of docs that kind of walk through the quick start. So I'm going to run out of time, so I want to wrap it up there. I know there probably are lots of questions. I see the little red light flashing, but I hope this has been helpful and you've gotten an idea for what's happening in the industry right now, how people are adopting this technology, and where it's hopefully where it's heading as we look out a year or two from now. Ankur, I don't know if there are some questions that you'd like to ask or that you want to highlight from the questions that have come in.
Hi, Shannon. Thank you very much. Great content. There are a ton of questions, and Matthew and I have been trying to answer as many of them as possible. But I think we can do some here so that everybody can hear the answers as well. Excuse me. There are questions about Kubernetes. There is a lot of interest in Kubernetes. There are questions about Rancher. I think for this session, it will make sense if I ask you to answer questions about Kubernetes in general. How about that?
Yeah, why don't we start with a couple, and we'll just go down as we go through the ones that are important to you guys.
Okay. I see a bunch of questions about Rancher, and I'm trying to find one that we haven't answered for Kubernetes yet. I think people wanted to know a little bit about how to get engaged with Kubernetes ecosystem in general, how to basically figure out what is coming out in Kubernetes in the future and be prepared for that.
Sure. Yeah. So, I mean, the reality is Kubernetes is a pretty easy space to get your hands around. It's the whole project is owned by the CNCF, so it has very good governance. It's very well documented what's happening. The releases are quite predictable. A lot of people talk to KubeCon about how Kubernetes is getting boring and it's kind of predictable, but the reality is that I would totally disagree with the last bit. I think that we're still just the beginning of adoption, and so we're in a place where the core functions of the orchestration layer and of what Docker provides are kind of standardizing, but building out platforms and stuff is still pretty early on. And so there's definitely a lot of debate going on right now about what's the right way, what are the right approaches to storage or security or networking models, or how do we sort of build these things like Kubernetes as a service. So what I would say is, in terms of places to get involved, a really good idea is to start joining some of the CNCF. Well, if you want to get involved in the programs, you can join the SIGs, but I was going to say just that we run online trainings pretty regularly. There's some great content there. If you go to the CNCF webinar series, you're going to find a lot of great presentations from different companies presenting on kind of unopinionated, non-vendory, how to use Kubernetes. Obviously, there's great training out there. A lot of companies are providing very good Kubernetes training. If you don't have a Kubernetes expert, somebody who's passed sort of the Kubernetes administrative tests and stuff on staff, I would start by engaging one of these training companies and get somebody up to speed on your team. So that would be where I would start. Certainly, I would recommend just getting going, getting a cluster up and running, deploying something, using Rancher to bring it up, or using GKE or whatever you want to pull as a way to get Kubernetes going in your org, and just start using the cluster and seeing where it takes you. Because I think it's relatively intuitive. I think a lot of people talk about how Kubernetes is hard. I think Kubernetes is easy. I mean, I think there's a bit of a learning curve like there is with any technology, but once you get past the basics, launching a container, setting up some basic health checks and stuff, it's pretty intuitive. So yeah.
Nice. Okay, there is another question which I think is very interesting because we have been working on some of these use cases. This is about edge computing. What do you propose when you have like more than 50 identical clusters, each in manufacturing plants, to run services with low latency and high reliability?
Yeah, it's a great question. I mean, when we're looking at the edge use case, there's kind of a core fundamental trait. I mean, Kubernetes is a really good option for this. The big issue with edge is always the amount of available capacity. So a manufacturing plant, a big retail store usually has a different ability of capacity than, say, like a base station or like a satellite station that's connecting to satellites or something. So, the first question is for like, how much infrastructure do you have available? If your constraint is, look, I can't get you more than one machine or three machines or a couple of VMs, or once you understand that, it kind of dictates whether you want to build out an entire Kubernetes cluster or maybe set up some kind of a micro Kubernetes cluster. And an entire Kubernetes cluster is ideal because it allows you to run kind of resilient nodes. You can do some health checks and failovers. Ideally, you'd even be able to have etcd distributed across 3 nodes. So sort of the perfect setup might be a 3 or even 6 node cluster that you're running kind of a small footprint of Kubernetes across some VMs or hosts locally that you can then deploy the same thing. We just made an announcement today, actually, of a new technology that we're rolling out in Rancher 2.2 called multi-cluster apps, which is exactly for the use case of I want to deploy the same configuration and same deployment to 50 Kubernetes clusters. And then I want those to be linked and upgradable and maintainable from a central place. So it does exactly what you're talking about, which is point to lots of different Kubernetes clusters and then effectively deploy the same Helm charts against all of them, and then be able to do centralized upgrade and maintenance of those. So the use case is spot on. The weight of Kubernetes, there's some work, we've got some work going on right now looking at how do if I can't afford those 3 or 6 nodes to run sort of a highly available etcd and a highly available set of Kubernetes nodes, what can I come up with as a resilient thing I can run locally to get maybe not at the same level, but a reasonably high level of resiliency for the cluster. And I think there's there's been some work to look at different databases on the back end instead of needing etcds, where you could use something like SQL that can be backed up and restored. Again, designing an application that fails safe if the Kubernetes cluster management layer goes down is another part of that. Designing the network in a way that doesn't really, maybe is not based on software, but is hardwired in. A lot of different options there for kind of building a robust edge level thing of Kubernetes. So it's probably worth a longer conversation, to be fair, but last year Toyota shared a really good use case where they did some interesting stuff there. Chick-fil-A has done some interesting stuff there. I think there's some great teams doing stuff like this. We're working with a lot of them to work on it.
Wonderful. And I just sent out a video for all of you guys to watch, which explains the multi-cluster applications that Shannon was mentioning. Basically, you can select an app, point it to your multiple clusters, and then just press a launch button, and that app gets deployed on all the clusters. So that should take care of some of these use cases that we were talking about. Okay, Shannon, a little bit more technical questions. Are you up for that?
Sure, fire away. Let's get into it. If I don't know the answer, I will tell you.
No problem. So very mundane question. Can you migrate IBM Cloud Kubernetes cluster to Rancher?
So migrating a cluster is an interesting thing. So there's 2 basic concepts around migrating clusters. One is, do I actually, so one thing you can do is basically mount a cluster. Think of it like mounting a cluster. You can import a cluster to Rancher. So Rancher allows you to run a command on, say, an IBM Cloud cluster that would then install Rancher agents on it, give Rancher visibility into what's going on, and allow you to implement a lot of the centralized tools we talked about, like user management and policy management, visibility, config of the cluster centrally. So that's not really migrating. That's just managing a hosted cluster, and that'll work on any cluster, but an IBM cluster will work just fine for that. If you actually want to migrate a cluster, like you're migrating off of a cluster, then I generally say, migrating is about just reinstantiating Kubernetes in a new place and running your workloads on that cluster and launching them there. Because it's the nice thing is Kubernetes is consistent. So, unless you're kind of doing a big change of version, all of your config files, all of your YAML files that describe your application will bring up the same exact experience wherever you deploy them. You might have to kind of configure storage slightly differently. You might have to look at, obviously you're going to have to look at your ingress and what the networking layer looks like in the new deployment that you're going to. So 2 approaches: you can manage that cluster, or you can deploy a new cluster somewhere and migrate that over. But a migration of workload is always the way to go. It's really, there's no magic of backing up etcd and launching it in some place. If it's different infrastructure and stuff, it won't really get you very far. I mean, there's people try things like that, but I would just generally say, that's the whole point of Kubernetes. You code everything up in YAML and relaunch. That's the right way to do it.
Yep, I totally agree. You mentioned namespace, and then you were talking about clusters, and you were trying to kind of distinguish between the 2, like where, when to do what. And I think the question is, how does the project's concept in Rancher fit into this?
Sorry, Ankur, can you repeat that question?
Yeah, absolutely. In fact, let me just read it. When comparing cluster versus namespaces as a service, how do Rancher projects fit in the comparison?
So yeah, Rancher projects are really just a group of namespaces, but
Namespace.
they're kind of important. What we find is that namespaces are, if you're going to do a namespace as a service, it's really hard to just give someone one namespace. And so the reality is namespaces, by almost definition, they can't run multiple versions of the same thing. And it tends to be really painful to allocate users a set of capacity for each namespace when they, if they're running 3 or 5 or 7. And so projects ended up being a really good delegated admin layer between. We don't really change anything in Kubernetes. It's all just namespaces, but we have a concept in Rancher that allows us to basically give user admin privileges over a set of namespaces that they can then invite people to, and that they can have sort of a capacity allocation against. So projects make namespaces as a service a little more feasible, is all I would say. It's not a major difference. It just makes it possible to give someone, instead of a namespace, give them kind of a tranche of namespace, or even give them the ability to create namespaces, so that you're not necessarily constraining them by a namespace, but rather you're constraining them to a defined set of namespaces that are allocated to them, and potentially a set of capacity that's allocated to them.
Okay.
My goodness, there are a lot of questions.
There are a lot of questions.
Someone just asked about the future of Longhorn.
Yeah.
It is definitely going to be brought to beta this in the very relatively near term. So they asked, is it going to be brought to beta or production state in commercial support? Certainly beta is the next step, and it's coming very soon. But yeah, we continue to invest heavily in it. We already are providing commercial support for a few people who are early adopters of it and running it in different ways. So you're welcome to reach out to us, and we're happy to talk to you about it. But yeah, I mean, like always, it's going to go through, in its storage, it's got to kind of go through its learnings.
Okay, there is a question about some real world usage, and I'm trying to find it. It was an interesting one. Like, what is the biggest challenge that you come across when you talk about Kubernetes at some scale? So is it monitoring, service mesh, anything similar, anything familiar? Like, what is the biggest challenge?
I think the community got it right when they were asked that question on the CNCF survey. That complexity becomes the challenge, right? It's, Kubernetes is really powerful, but as you get to, the more you add to it, right, the more intricate your consumption of it is, the more the components that you start to use. You mentioned service mesh, Prometheus, monitor, all these pieces. You do start to get to a point where management of the stack that I was talking about earlier becomes a lot of work. And, I would say that's kind of impacting our vision at Rancher, and that we've always kind of believe that people need a lot of flexibility in choosing their own tools, but over time we have started to build in kind of a toolbox of services, and the first of these was sort of monitoring and logging with Prometheus and Linkerd and Fluentd, I should say, and those things. It's not that we think those are necessarily the only way or the best way, but what we're finding is that by maintaining a really good implementation of Grafana and Prometheus and have that be implemented, it meets a lot of the 70% requirements, right? So maybe half or 3/4 of people, it's more than enough for them and the requirement they have. And so I do think that will be, that's a really good model to use going forward to deal with some of this complexity, is to take some of the other projects that, Istios is on the list, that it clearly add value, that could easily be set up and configured in lots of different ways, and begin to incorporate them into the platform so that there's a default implementation at the very least that you can choose from. The key though is making all these things optional. It's when it breaks down is when you say this is the way to use it.
Yeah, absolutely. And I think what I would like to add there is, in the more recent surveys, Shannon, we are also seeing security coming up as one of the top level issues that people face, or at least they think that they face.
Yeah, for sure. I mean, security is one where I think there's also kind of 2 or 3 levels of security, right? There's, we talk about pod security policies and user roles, image scanning. There's a lot of things that you think of more and more now as kind of default, security that needs to be there. And then you've got the work that Aqua and Twistlock and stuff are doing, which is really impressive to extend security and do even more. So, kind of as always, it's sort of security in depth. It ends up being the answer. Ankur, we probably only have time for one more question. So maybe do you want to pick one, or do you want me to pick one?
Yeah, please go ahead. You pick one.
There are some really, really long ones here. Guys, thank you so much for so many people coming, asking so many awesome questions. Sorry we can't stay on all day and answer them like we do with our meetups, but we will try to get back to you. Brian asked a question. He said, can a Kubernetes deployment continue to run without Rancher being online? We see a dependency between them. It's a good question. I mean, architecturally, absolutely, the Kubernetes cluster will continue to run. In fact, it's sort of three levels of this, right? The Kubernetes nodes themselves aren't dependent upon the Kubernetes master. They expect, they're designed to expect the Kubernetes master itself could go offline, and they'll continue to run. And we've built Rancher in the same way, that Rancher going offline should not impact this. Now, where it does impact things is things like single sign-on and proxying access control. So across the board, there's like impact at these levels. So while the workload continues to run, if Kubernetes masters go down, you can't make changes to it, right? You can't increase the scale or restart a service or address something else. And very often you do see, kind of issues with, say, a Kubernetes process, like when the Kubernetes master goes down, maybe the reason is because there's capacity constraint somewhere that's causing an issue, and that might bubble over to your networking infrastructure or networking implementation. So while the Kubernetes while it's true that the systems are kind of independent and they should be fault tolerant for each other, there is impact when these things go down. And so we do generally, everything is geared to continue to improve that experience where, the management layer of the technology is has less and less ability to impact. And I think at Rancher level, we're working on some things right now, which like today, we proxy API calls and stuff to enforce access controls and to ensure that, that the policy you're setting is actually being implemented. We've just built some stuff now that allows that to kind of be addressed and bypassed, where even if Rancher is offline, it allows you to go directly to the cluster and have those same security policies get implemented. So there's work to be done at that level all the time. I think, Brian, good question. Yeah, I mean, so many good questions here, people. I'll try to maybe write a blog or something, kind of answering some more of these. But if you'd like, we'll be on that masterclass channel. If you have a question that was really pressing that didn't get answered, please jump on there. Ankur and I will be in there. We'll try to answer as many of them as we can. And with that, I just thank everyone for attending today. I hope it was useful. Hope the presentations, we will post the presentation itself on SlideShare. So if you need anything, please don't hesitate to send me an email, Shannon@rancher.com. Happy to answer your questions.
All right, thank you very much, Shannon, and thank you everybody for joining. We were really excited to have you here, and please keep reaching out to us and keep an eye on the Kubernetes Master Class Series. There are tons of good sessions just like this one that are coming up. We have something scheduled for almost every week from here till May. All right, awesome. With that, we can sign off.
Thanks a lot, Ankur. Have a great day, everyone.
Bye.